So this is the blockchain and new COSM architecture panel. We have quite a great group for today. Essentially, we're going to open up with brief opening statements. What I told the panel was, hey, be ready to give your opinion about the future of networks, which shouldn't be a problem. We're coming from slightly different directions and perspectives. Gurdeep is a long time, maybe back into the 90s, Gurdeep, from Microsoft. That's quite a journey. So I have sort of Gurdeep as my representative software. We have Dan Mapes, also a long-time technologist, and hits on, his company has verses in the title, so he's hitting right on metaverses, and so he's my expert on metaverses. And Bob Metcalfe, yet another person that doesn't need an introduction, is my go-to person on connectivity. And my name's Daniel Berninger. I'm essentially the closest thing that you have on the agenda as a telecom person. I'm George's, for about a decade now, bridge to telecom. Telecom are those guys that are down in the basement trying to make stuff work. And I've cleaned myself up and come upstairs to talk to everybody. George included me as chapter 20 in Life After Google. And so what I'll talk about and sort of set up for the panel is what is COSM architecture. But for a starting point, what I'd like to, it's very easy for the panel to say, oh, just more of the same, right? So they're essentially world-class experts in their particular field. But I would argue, really what COSM, this event is kind of pulling out with the notion of these paradoxes, is that essentially the paradoxes, these are not happy paradoxes. They're all kind of the same. They essentially have sort of a phrase like, well, we thought that was going to go well, but didn't. The paradox is that a trillion-fold decrease in the transistor didn't turn out uniformly great for everyone. And so what I'll ask the panel, and I'll do myself, essentially is whatever I'm describing about the future, contemplate or sort of juggle with the paradoxes. And that we kind of have the rule of the hole is stop digging when you find yourself in the hole. So what I'll ask of my panel, and I'll kind of maybe push them a little bit, is, well, more of the same isn't going to do it. We need to resolve these paradoxes. And so what is COSM architecture? We'll call it the new COSM architecture. And I'm, to some extent, waiting until George comes out with a book to tell me. But I'm going to sort of guess at what it is. When's the book coming out, George?
Next year.
Yeah, so another year. So basically, his next book is Life After Capitalism. He has a good essay out there in the National Review explaining it. But let me just hit on real quick. So the COSM, the information technology of economics, is an implementation of Shannon and the ideas of Shannon. And so a COSM architecture that implements information theory of economics is implementing Shannon. Okay, so let me just talk about what Shannon is and why Shannon isn't quite where we are right now. The paradoxes, ultimately, I will argue, are the result of sort of faulty thinking or messy thinking about some things. One, about time, for the first part, and two, about human purpose. And the reason Shannon is so important, and it was sort of a genius invention that he made, that Shannon worked for Bell Laboratories, he was a telecom guy, was that he created essentially, you're faced with a problem when you're building something. You can't take into account all the human uses of the thing you're building. And so, in the 40s, you're looking at the telephone network. When you're refining the telephone network, you can't say, well, you can't really take into account all the possible conversations that are going to happen. So you have to abstract out and pull out and decouple that issue. And then again, any architect of let's say of a building, they can't take into account what the owner of the building is going to do next Wednesday. They have to have an abstract idea that they're trying to shoot for that accounts for and optimizes the human use of whether it's a building or a telephone network. And so what Shannon did was he encapsulated the human aspect of the telephone network as a message. And he built a machinery apparatus around the message that we're going to figure out how the most optimal way to deliver the message. But the key thing about the message is that the message is not like, delivering the message is not like delivering the cake by FedEx. No, the cake isn't arriving at the other end. The message is a recipe to recreate on the other end voice or whatever it is you're trying to recreate. And so the tools of information technology move what is a physical thing like my voice right here and now, in person, creates a representation of that and figures out how to get it to the other side. But the key thing about that process is that what gets to the other side is not real. Like when I talk to you on the phone, it's not my voice, right? It's a recreation of my voice. It's a simulation of my voice. And the thing about simulations is they do not turn into the real thing itself. You take infinite time, infinite compute, infinite memory, infinite connectivity, and you're not going to turn the simulation of an apple into food, right? It just isn't going to happen. So to some extent, I don't care how much compute you have. You're not going to go from simulation to the thing itself, okay? And that's straight out of Shannon. Now I should say that, and then Shannon went about and ignored his own insight. And he signed up with John Wheeler and Marvin Minsky to create something called the Summer Conference at Dartmouth. And they made a proposal to the Rockefeller Foundation. I'll just read the proposal to you. And the proposal essentially instantly forgets what he just invented. He said, and this is 1956, this is the statement essentially that got us to artificial intelligence, and this is a very nice description of what artificial intelligence still is today. In this Dartmouth proposal, they said, and again, in 56, this is pre-computing almost. I mean, it's like the transistor got a Nobel Prize in 1956, or the founding team. So what they're saying here, in 1956, the study is to proceed on the basis of the conjecture that every aspect of learning or any other feature of intelligence can, in principle, be so precisely described that a machine can be made to simulate it. Now, I'm not going to take time to parse all that, but at the end, it makes an admission that they are simulating it, okay? And so in 1956, they're launching AI as a simulation via a perfect description of intelligence. And what we just said previously is, no, you can't get to intelligence by simulating it. Whatever AI becomes, it remains a simulation and cannot accomplish intelligence. And essentially that statement, and you can look it up yourself, search Dartmouth proposal, they're essentially violating two things in that statement of the quip that says, well, you can either predict what's going to happen or when it's going to happen. Okay, they predicted neither. Okay, there's no time, and so essentially AI is constantly over the horizon because they're not telling us when it's getting here. And they're not exactly saying what they're going to do. But Shannon in 1948 said, no, you can't turn a simulation into the thing itself, full stop. All right, so as a start, we're going to go alphabetically. Dan Mates, tell us what you think is coming.
Thank you, everybody. So great to be here. Big fan of George, years and years, and obviously this man to my right here, amazing. Metcalfe's Law, can't beat that. So my company's called Versus Technologies, and we're the inventors of a new set of protocols that really implement many of Bob's really exciting ideas that are built into Metcalfe's Law. And it'd be fun to have him actually say what it is here today, Metcalfe's Law, just for all of you, so you get it from the actual source. But essentially, our current web is a web of documents. And it's basically web pages. and the protocols are hypertext transfer protocols. But we live in spaces. But our web couldn't handle anything in 3 dimensions back in 1995. So we were limited by the bandwidth of the networks and by the chip speeds to downloading web pages. In fact, we could even watch them download on a 56K modem in 1994. But since then, chips have gotten faster, the networks have gotten faster. We got 5G, we got Starlink, we got a whole bunch of things coming. We got chips that are crazy. We're watching Netflix on our smartphones. And so we need a new web. If we're going to run smart cities, if we're going to manage the planet, if we're going to manage where drones can land and fly and all these kinds of things, we need a 3-dimensional web. We need a global web. We need a spatial web. So we wrote a book called The Spatial Web, and we invented spatial protocols in partnership with IEEE. We have the IEEE committees now. They'll be probably being published. The drafts are out already. They'll probably be published here in the next 9 months, becoming a standard. So it's instead of a hypertext transfer protocol, it's a hyperspace transaction protocol, because we do transactions in and between spaces. And it's not just humans using that. That's an AI as well. And it's not limited to 3 dimensions of space. It's space-time plus any other n dimensions like temperature, weather conditions, other kinds of things. So, so we've got a hyperspace modeling language, just like we would have a hyperspace language for making web pages. Now we can program web spaces. So what that gives us then is a global, a hologram of the entire Earth. Microsoft, in their recent flight simulator game, they're putting out a 4K resolution digital twin of the entire Earth. And the company that worked with them to do that has now just raised another $20 million to really make an absolute digital twin of the planet. Many cities are making digital twins of their own cities. Buildings are making digital twins of themselves, factories. We've been implementing the spatial web into a digital twin of various warehouses as a test of its capabilities. So these are advanced electronic warehouses. And when we make the digital twin of it and turn the AI loose, guiding all the workers through it, we're cutting overheads by 30, 40, even 50%, because the AI is, it knows where everything is in the digital twin and can guide everybody to things in the fastest way possible. It reorganizes the entire warehouse mathematically so that things are near where they should be. Training times drop from 2.5 days down to 30 minutes. Crazy application. So the spatial web will just rip through the world. Our client base is already companies like Honeywell and some very big sneaker companies and other big brands that you would all know. Some of them not yet to be announced. We're going public in January. Things are growing fast. We just won in partnership with Microsoft. The European Union was very concerned with drones. In the Middle East, a lot of people were buying Chinese drones and slapping explosives onto them and flying them into buildings and things and blowing them up. And some smart people in the European Union went, you know, we probably ought to address that for Europe. We got some terrorists of our own. And so they put out a call for papers, competition. Hey, look, let's take 5 cities in Europe and let's figure out how do we do drone management across countries at scale. Anybody got any ideas? You know. And 80 consortium groups applied, all the top names you would expect. And we partnered with Microsoft, and we applied. We were a young company at the time. I think at that time, about 1.5 years ago, we were maybe 25 people. Now we're 50. We won. So we and Microsoft are designing the drone standards for all of Europe. And again, we've turned all of Europe into a hologram. And then every drone is registered. And just like a car, if you're not registered, you're pulled over. And so now if we've got a drone in the sky that we query, it's near some critical infrastructure, and it's not registered, we may choose to just take it out with a laser or send up a Hawk drone and grab it, bring it down and take a look at it. And so that's why we won the contract, because we look at things spatially and dimensionally, but not just geospatial, but we look at things as a giant hologram, and then within that hologram, then the AI can operate effectively. And then we have a new kind of AI as well. We're not just using ML. We're working with University College London, which is where DeepMind came from, and that's why DeepMind is based in England. So there was a group of PhD spin-offs that started DeepMind, and then Google came in and they became part of Google. But the primary professor there, the #1 neuroscientist in the world, Dr. Carl Friston, he didn't go into the DeepMind group, even though he helped develop it. He was working on something called active inference AI. We're very excited about it. Instead of DeepMind, it's a nested mind, so that'll kind of give you a flavor of how it might be working. And of course, spatial computing has to be nested as well, because if you have a domain, you have a new DNS, you have a domain that might be a restaurant, it might be in a building, the building might be in a city, the city might be in a country, and you've got to inherit the laws and rules and all the way up and down. So you can say no shirt, no shoes, no service, but you can't discriminate based on race or anything like that because you've got a federal law up here. So your domain system has to be nested as well. So we've wired those two systems together, and we have a nested AI system, and so we call that embodied AI. So the web itself becomes the body of the AI, and AI at every node. I thought Iron Man got something really right with Jarvis. It's kind of like, hey, that's an exciting possibility. Having an AI that's like that, we're going to have that. We're going to have Jarvis with us. But the thing they got right was the augmentation of the human by Jarvis, so he could work together. What they got wrong was there was only one Jarvis. Well, Jarvis is software. Make me 8 billion copies of yourself and give everybody Jarvis. Right? And so we're going to have 8-year-old girls in Kenya in 8 years with more compute power and more AI than the largest corporation in the world has today.
So Dan, I'm going to let Bob speak.
That's a quick look at how I see the view.
So Bob, how would you grapple with the paradoxes from the perspective of connectivity and more connectivity?
Am I on the right panel? Could you imagine tying those two together? The internet is this alive? The internet began operation on October 29th, 1969. So it's about 52 years and 12 days old. When the pandemic arrived a couple of years ago and we all desperately tried to figure out what to do, the internet was there. So we all turned to Zoom, and Zoom worked. You're welcome. So my view of the future of the internet has to do with how that phenomenon, that is the use of the internet as a remote connectivity tool, is going to affect work and education and so on. So for example, the new university we heard about yesterday, Niles University, he's against online education. So that's one of the debates going on, is the professors, many professors believe that they need to be in the same room with their students in order to effectively teach them. But we just finished spending a year where every professor at the University of Texas taught every course online, and it seemed to work. So I think education is about to get substantially disrupted by the arrival of Zoom and its descendants. And that's a hot area of innovation right now, is how to organize and project those kinds of conversations remotely. It'll also affect work. And in this period, I learned there's two reasons why I go to work. One is to be with my colleagues and my customers. But the other reason is to get out of my house, because your house is full of to-dos. So I think there's going to be an implication on the future of the internet. Is there going to be a new kind of real estate? It's the place you go that's not your house, but it's not your job either. It's a place where you can have the best of both worlds. So maybe WeWork wasn't such a bad idea after all. Is that enough?
Yeah, that's enough. So Gurdeep, now you quasi started out in telecom within Microsoft, and essentially were responsible for, I guess, Microsoft ingesting Skype and what to do with it, and how it would live inside Microsoft. And so what's your perspective on, what's next?
Well, firstly, I would say that I'm going to go call my dad and tell him thanks for giving my last name with P, so I have to follow you, Bob. I think that's, how can I follow Bob?
Exactly.
My entire career,
It's like following the elephants in a parade.
all I can say is my career, It was much better than that. But my career has really been following your work. In the 90s, I worked on the TCP/IP stack, which went into Windows. That just getting that and bringing the world online, and Windows played a part of that because TCP was built into it, was really, that was my first decade of my career. My second decade was communications. So what is Teams now? I started that whole effort, ran Skype for 3 years, which is really building on top of the internet. And then my last decade, if you will, has really been about artificial intelligence, a lot about what he was talking about. So, in terms of where things are going, and I'm going to take a very software-centric view of this, if you look at software in general and software on the internet in particular, it's always been about getting as much possible done for as many people possible, given all the constraints that are there. In the 90s, the constraints were that we were hardwired. Thanks to the Ethernet, and then, of course, with optical coming in the backbone, we created a hardwired network, which enabled a lot of stuff. We were able to get to information. We were able to do messaging, asynchronous messaging, but we got a lot done. We were even able to get some transactions done. This little company across the lake basically allowed you to start doing e-commerce with very, very atomic point-in-time transactions. So just about the time when we figured that out, Wi-Fi came along. In fact, I was the general manager for getting Wi-Fi onto Windows XP for the first time. And the next decade went in trying to make Wi-Fi work. I mean, that was the flakiest thing in the world. And when we figured out how to make Wi-Fi work, suddenly people wanted to work from anywhere, and they started to want to use cellular networks and mobile networks. And they were flaky as anything. Now, having worked through all those different challenges of speed, quality, and reliability, we are on the verge for the first time being in a place where we have very fast networks. We can work from anywhere thanks to 5G, and we have very high quality, low latency, low loss, low jitter. So question is, what are we going to do? And I think this is, especially when you bring in some of the AI elements, there's going to be a fundamental transformation in architecture of software. In particular, we are going to see, building on things like IoT, we're going to see a distribution, or what you call distributed processing or decentralization, where the state, the actuation, and the compute can all live in very, very different places. It is going to get distributed across heterogeneous compute units, separated sometimes by feet, sometimes by continents. And they're all going to be working together. You can call it the Borg, you can call it whatever. But we are going to end up with a level of decentralization that we've never seen before because we've gotten there with networks now.
Okay,
We call that the edge? Is that the edge?
So let me, I'm the moderator here, Bob. I just want to have a follow-up that essentially, so I'm on Team Human, okay? So I'm like, well, I don't care about distributed computing, okay? I care about the experience of the human. So if you imagine, and I'm essentially calling myself an architect of communication networks, I care about the experience of the end user, the human experiencing those communication networks. I don't care about the bits and parts. And just to give you an example, so Steve Jobs, when Apple came out with the laser printer, he said, the engineers were telling me about all the good stuff in there. I don't care, he said. That he picked up a piece of paper and says, oh, look at this outcome, this human outcome. And so the thing that gets lost in all these conversations is there's humans behind everything, right? And there's human outcomes behind AI, machine learning, everything. It's all humans. Machines aren't crafting up to take over the world. But the nuance is, and this is a plug for COSM, and what COSM is saying differently, and what ultimately Shannon said. Shannon ultimately said, look, I'm creating this abstract model, but at the end of the day, this network exists to deliver conversations, human conversations. And there really isn't, we don't eat the hardware, we don't eat connectivity, we don't eat software. We don't eat user interfaces. And so we have to grapple, and I think that's the heart of these paradoxes, that the paradox is coming from that all these outcomes are not necessarily serving the human factor, and we can think of it in terms of it's not meant to, in the sense that what Shannon said, the telephone network was emphatically just delivering conversations, and it still does, right? So it doesn't discriminate. You can be a really bad person and still make a telephone call, and they're perfectly happy to deliver it, you know. And so it's just emphatically serving a human purpose. Now the internet was originally theoretically going to do that and be more, you know, it wasn't sort of top down like the telephone network. But it's not clear that that's where we are today, that AI is essentially ingesting real-world information, not necessarily for our purposes, right? So I think Peter talked about the surveillance AI. That's not for our purposes. So as we just kind of describe this future, I'd like to hear, I'm a human being, tell me why I should want more connectivity. I want more software. And I want whoever wants to take that, and I want to see it. You know, I want to put on glasses and see this augmented reality. You know, that you're proposing.
Yeah. Well, the good thing is that it's coming whether we like it or not. So my deal is if it's coming, then we need to engage it and then bend the arc of it in a way that is safe and serves us. But AI is coming, and holographic environments loaded with data are coming. We're going to shrink wrap our planet with data, so that's all coming.
So can we just poll the audience? In other words, again, Peter was saying, he gave up and said it was a political question. Do the people want AI emphatically? Raise your hand if you think it's coming, whether we want it or not. Okay. You win that one.
Why does the AGI want to kill us?
Exactly, Bob. I agree, it doesn't. No, it doesn't. It doesn't. Of course, AGIs aren't dumb. They can read all the philosophy as well, and they realize that going down the evil path is bad karma, so they're going to do the right thing. But I think when we look at what it can deliver, what we have in our body is an autonomic nervous system. And I'm not having to adjust my heart rate all the time when I climb a set of stairs. It just does it automatically. And so what Bob's done is he's laid down his networking world that he has helped bring to life, has laid down a nervous system all over the planet. Now, the good thing about that is, from an engineer's point of view, like I am, wow, what a leveraging factor. There were 4 computers plugged into the internet in 1969 when they did the first test. There's 40 billion today. We're about to plug 400 billion IoT devices into it by the end of the decade. They're all going to be on the network. Well, then, a piece of software, friction-free, runs all across the network. That's the value of protocols. So if we look at, Bob went back to 69, but let's go back to 44. I mean, the first programmable computer was built to crack the German cipher, Bletchley Park there, the Colossus, and 25 years later, on the dot, 1969, internet, 25 years later, on the dot, World Wide Web, 25 years later, on the dot, the spatial web. Now, that's partly Moore's law, partly Metcalfe's law, because once you get what Metcalfe's law delivers, and I'll just paraphrase it a little bit, is exponential results. The mass production was great, printing press was great, delivers scalable results, but networks, they deliver exponential results. When you get exponential results, if you know economics, then your marginal costs are going towards zero.
Yeah, but I don't want, again, in the original framing, I said, I believe that we've dug ourselves a hole. And so if somebody says to us, well, you're going to dig a hole exponentially, I'm not thrilled.
No, but if you've got a nervous system, what it does for us is homeostasis. We don't like it when we're 3 degrees below our proper temperature, 98.6, or 3 above. So we got the same problem on the planet.
Again,
that network can help us manage the planet.
So my specific thing, what I'm asking my panel to grapple with, or tell me they're not going to grapple with it, is that who is it serving, right? In other words, so we had Douglas Engelbart, as a pioneer. He died a few years ago. He created the mouse. He thought of the computer as an augmentation, as a tool for human beings. He didn't imagine that computing was going to replace humans, okay? And Microsoft, the basic Microsoft business is a productivity tool. The operating system served humans and created a very big company doing that. But you could look at what's going on, and well, who is that to serve, right? So, life after Google, I think George is essentially saying, well, who is that serving? Is that serving the end user population. No, I mean, in the sense that their entire business model. You try to call Google. Has anybody tried to call Google? So my wife, for example, lost her whole Gmail, which is a big deal. No one to call. So in other words, you're not their customer, right? The customer is the advertiser. Life after Google makes that clear. So I just want you to grapple with this. Who is it serving?
I mean, it's always serving the end user. I mean, the fact that there are commercial interests in serving the end user, that can be put aside for a second. Just look at the AI scenario. In fact, I'm going to borrow your example. In the same way the human body regulates its temperature and metabolism and so on, today, if you look at how we live our lives, the systems are super dumb. Even if you have a Nest which is supposed to be smart, it's actually really dumb. And why is it dumb? It's dumb because today we have silos, which are artifacts of the old architectures, which are how networks were built and how software stacks on top of them were built. Today, when I'm 5 minutes away from my house, why doesn't all the heating and lighting in my house fix itself? The reason it doesn't work that way is because we have these silos, and the heating system, even if it is connected to the cloud,
that's not exactly true, Gurdeep, in the sense that the reason it doesn't happen is because all the headlines of all the cyber problems that the architecture of the internet, which is 50 years old, it was meant for 100 nodes, not 100 billion nodes, and essentially, again, just a quick architecture point. Everything that happens on the internet that you experience happens on the end boxes and on the phone or whatever. So if you are going to be protected by some bad guy in Ukraine, all that protection has to happen on the end device. The network itself is dumb, doesn't do anything. It's completely sort of transparent for every bad criminal or whatever. And so you have to architecturally, how do I, as an individual smartphone, protect myself from billions and billions of devices? Not so easy. But go ahead.
Well,
I'm saying that's why it's not happening, because it isn't safe to happen.
No, I think today there are distributed. You can do security today in a way that you can truly get security in a distributed architecture.
Okay, but again, Gurdeep, nobody has security. So how could you say that?
What do you mean nobody has security?
In other words,
today
who feels secure about putting their whole lives on the internet?
So,
go ahead, Bob. Bob did.
Yeah.
Go ahead.
Yeah, no, there are new. The other thing I think we have to be aware of is you can't see over the horizon. I mean, there are going to be breakthroughs that are going to shock you and blow your mind, and you're going to go, "I was wrong." Things happen that you can't predict. We're working with self-sovereign identity as an example. That's a new thing. When the original World Wide Web was developed, there was no identity layer, so we have to log in everywhere, and you're tracked. If you have self-sovereign identity on a blockchain, then you can have zero-knowledge proofs, other kinds of levels of security. You also have contextual knowledge now because you've got AI at all the nodes, so they can notice when something weird is happening. Oh, that's actually coming in from Nigeria. It's not a person down the street or whatever, and you do get new levels of breakthrough. So I think it's better to be humble and be open to the future.
Well, no, I'm Mr. Humble over here.
Things are going to blow your mind in this next 10 years.
Yeah, but what I want to be careful, and Bob, you can correct me if I'm wrong.
I don't understand what your complaint is.
Yeah.
So we have security problems. Is that your complaint?
Well, we have a network that's unsecurable, is my problem, because of the architecture. The architecture requires all the functionality to sit on the end boxes. And so by default, written in Vint Cerf's paper in 1972, every box will have, every sort of process will have the right to create a message to every other process on the entirety of the internet. And so the decision of whether or not your smartphone talks to some other box anywhere on the internet belongs to your smartphone, not to you. The moment you download any piece of software, that software has the right and the ability to talk to the entire internet, the entire billions of, and as far as creating functionality and connectivity, that is a fantastic thing. And that blows away what the telephone network was delivering you in a 3 kilohertz voice signal in this network that was about 100 times more expensive than the internet. But nonetheless, I still think you've got a problem on both sides. The internet is essentially a reaction to the shitty service, the shitty voice service, in which, by the way, we still have shitty voice service, that the telephone network was, and just flipped But now we've created essentially an opposite problem. Instead of having not enough functionality or very little that never changes, we have essentially too much.
But it's easy to agree with our moderator.
Yes.
You're not moderating, you're exacerbating.
Okay. I'm provoking.
But we all agree.
Yes.
There's a security problem,
Yeah, of course.
and you're working on it.
Of course, there will always be a security problem. We can decide, do we want to secure the endpoints? We can decide if you want to secure the network. If you want to secure the network,
But that's a talking point.
The quantum internet.
But again,
wanna
you're like
store
a roofer that says there's always going to be roof leaks. No, there isn't always going to be roof leaks. Fix the roof.
Yeah.
Okay.
So
I move that we fix the roof.
Okay.
Can we move on to the next complaint?
No, I want somebody to respond.
More moderation, less limitation.
Yeah, I want somebody to sort of grapple with essentially the point of all the paradoxes, all of the essentially that the internet, whatever it is, has diverged from serving as a tool in the sense that Douglas Engelbart meant, and is turned into an automation engine to displace humans. And per my opening statement, it can't. That essentially humans are unique in the sense they cannot be replaced by a computer program for entropy reasons that Shannon talked about, that George has written 20 books about. It just can't be done. And we've gotten to where we are sort of as a car out of control for 50 years. And I'm just saying, well, we're in it with a bunch of paradoxes. Like, for example, when I come over here from the airport, you're driven by a taxi driver or an Uber driver, you're essentially dropping into poverty for the distance that it takes to get to here. Bellevue is essentially Shangri-La. It is a wonderful place, but it is essentially a function of the benefits that the humans that live in Bellevue and our surrounding areas get. The humans have benefited from Microsoft, from Amazon, and they have essentially created an ecosystem for themselves. But outside of Bellevue, I'm not fully sure that it's worked out that way.
So this is a new complaint. Now this.
It could be. All my complaints are the same in the sense that, and again, to echo, I'm not coming up with these on myself. I'm echoing George, and essentially George has written 20 books and saying, this government bureaucracy, all these are not really serving the human, and it could. And so I'm just arguing from Team Human. Anybody else here a human?
No, but we're not. But I think the bottom line here really is we're not here to argue. We're not here to argue. What we're here to do is share some visions. And some of you will respond to those visions, and it'll trigger things in you that will be valuable in your businesses. And so my vision may not be acceptable to you, but it may be very valuable to somebody else here in the audience. My vision is that we are an evolutionary species. And we use tools as part of our evolution. And we have no upper limit to our evolutionary capabilities. And when we increase the bandwidth and the capabilities of our networks, which allow us to have these global conversations, then we increase our evolutionary quotient. And so we are on the cusp of a golden age. That's what I actually believe, and that's what I'm here for. That's what I'm delivering. That's what my code does.
Let's talk about evolution. Bob, do you have any thoughts on evolution and as singularities and all that?
Darwin was right.
Yeah.
Bob's great, isn't it?
So here's my objection to the evolution argument, and that is at some point. So for example, if you go to Rocks to Birds, I posted an exchange that I had with a singularitarian, David Orbach or Orban, and we had a back and forth similar to this one. And I was saying, look, at the end of the day, Geppetto had animate wood to turn Pinocchio into a real boy. Where's your freaking animate wood? Okay? That at some point, all these things you're telling me about this magical future requires a miracle that turns a computer, which is dead, okay, I'm afraid it's dead, to a living thing, okay? And when you say that computing will surpass humans, you got to first decide what a human is. right? And essentially 20 books. George is saying, no, we don't know what a human is. We're not quantifying what a human is. When, we don't know what the universe is. So when you look at, let's say, a rainbow, you see these colors, but the rainbow is really not there, right? And essentially, it's a combination of light and raindrops or whatever, but it isn't really there. And so we as humans really have no clue what the universe is. And we can measure it, and we can kind of say, well, the tree is 100 feet tall. But you cannot get from a measurement to the thing itself. I can take a ruler, and I can, per the Dartmouth thing, create a perfect description of the tree. But the tree's not made out of rulers, right? In other words, the tree is a thing of itself, and you, with all your measurements, or as in the simple example of voice, we do a job to take voice from point A, which is my real voice, and even with respect to this microphone, but what you're hearing in the room is not my direct voice. It is a representation, and you cannot, in any, whatever compute power or Moore's law, turn a representation into the thing itself. That, and as I said, you can't turn an apple into food.
So we've moved from computer security to the very big question of whether computers can ever be alive. Am I following you?
Yeah, go ahead.
Far? Yeah.
Do you object to that?
I think computers can be asymptotically close to alive.
Mm-hmm.
Just some more.
So, and I didn't finish my quote. So go to Rocks to Birds, and I'll get back to you. So what David said, I said ultimately, after I gave the Pinocchio animate wood comment, I said, look, you cannot turn a stone into a bird. And his response was, no, that's exactly what evolution does. Turns a stone into a bird. And again, I argue, we sort of, in all these discussions, switch over to, miracles that supposedly are going to happen. Now, keep in mind, the Dartmouth conference, which described what AI is, absolutely, we are now a trillion-fold compute beyond that point, and AI is still over the horizon. I mean, anyway, I feel like I interrupted you, Bob.
No, so Marvin Minsky was my thesis advisor.
Excellent, yes.
So I've been disappointed by AI ever since the 60s. But I think this time AI is going to catch on, or is catching on, because what AI feeds on is data. And the previous instantiations of AI didn't have data.
It was trying to get a perfect description that they would then simulate, but the data one, it's not a description, right?
But now we have the internet that can bring data to the AI. So this time the AI is going to succeed because the internet is here to deliver connectivity to data.
All right, now you're Mr. AI, so go ahead.
And I mean, I think Bob's right. This is the first time, because digitization, we have data that we can, and our models are getting better and better. I would actually take a step back and say, I think this whole problem, the way you stated, is ill-posed. Because to me, humans, since the beginning, have always found tools to help them get their work done and to live better lives. And
so we're agreed on that. So that's your premise. We're agreed on that.
So where we are is, it's not so much that can this tool be as good or better than a human. It is that with all the limitations of the tool, can you make the lives of humans better? I mean, today, if you just look at AI, just look at the state of the art in GPT-3 language today and translation. Today, a single model can translate between 50 languages, which is way better than any single human can do. But it may not be as good in translation, even one of those languages, if you bring an expert human who just does that one language. So my point is,
let's not leave that point, right? So where does that capability come from? The ability to translate. It comes from humans, because essentially they take human data, the surveillance AI, and they ingest all that data. Just like it's not any different than ingesting voice and then pushing out voice on the other side.
Sure.
In other words, the telephone network has no idea what voice is, just like computers have no idea what it is that they're ingesting, and you push that out. And so they're essentially the relationship to like machine learning and to AI is essentially the relationship of an apple to applesauce. In other words, you've taken the apple, you've chopped it into little bits, you have no idea what is an apple, and you've created applesauce.
But there's no difference between AI and a caterpillar digging up my front yard right now. 50 people ingenuity went into creating that caterpillar to get its job done. It does that job really well. It does many jobs in a bad way.
So we're together on that.
With language, so I think, we should look at AI not as this, have this crazy bar, is it matching humans or not? It is that it has a particular set of strengths and weaknesses, but in the end, it is a tool that is here to make our lives better.
All right, Bob, Dan.
We generally don't even call that artificial intelligence anymore. It's networked augmented intelligence. It's the human and the AI working together as a tool. What you do when you build something like a network like we have with the internet, and now we're going to extend it to every IoT device, then you've got a new user of that IoT network, and that is the AI. And what's the AI doing? It's building a world model. That's a world model. And once you've got a world model, now you can optimize that world model. Supply chains, whatever the problems are, carbon footprints. We're working with the World Bank right now on new carbon accounting models. So once you've got that better world model, suddenly we can manage the planet more effectively. We have a question back here. I guess you want to take a question?
Well, hang on. Did you go ahead? You have to go to a microphone for us to hear you. And then I'm going to change the subject again, so Bob, get ready. And you had some... A blockchain.
Okay, I've been dying to ask this question. I love the idea of maybe a bot in my body who can tell everything that's wrong and everything I need to do and all that kind of stuff. But when you're talking about data and the human is the end user, and that's who you want, the data that I want is all the data. I want all the info coming to me, and I don't want someone censoring what I hear, and so I only get maybe a third of the data that I want because someone else has decided that data it's hate or it's pornographic or whatever it is. I want to decide that. I want to block them, and it's so unfriendly to me as the end user human to have, when you're talking about data. I don't care if it could. I could get blocked.
All right, so I get it, and we're going to talk about that right now. So I'm going to agree with Gurdeep, everything he said. Essentially, we can define technology as essential in the context of time, that anything that saves time, okay? I mean, a technology that saves time, all for it. Okay, the washing machine saved time. Let's have washing machines. And so whatever it is that we're doing with AI and compute, et cetera, is saving time. I'm all for that. But here's the COSM distinction. Okay, whose time? Okay, whose time are we saving? The way George says it is Ben Franklin told some tradesmen, hey, time is money. Okay, and George says, no, money is time. Okay, and what that just means in that switch is whose time, right? So with money, you can buy a whole bunch of time. You can essentially buy infinite time of humans. And from the individual human perspective, you can make money with time. But the catch is that as an individual human, and this kind of gets at what is time and why we want to save it, is that you have a finite amount of time. So if you substitute, for example, every time you want to use time, substitute in life force. So I would say to Bob, do you have the life force to spend some time on our panel? And so Bob would calculate and say, well, I don't have the life force, Dan, to do this. I'm annoying him as it is. So what COSM is about in all of George's books, and I don't want to speak for you, George, is essentially, time is so important because it is finite. Our life force, our lifetime is finite. And that essentially is the difference between something that is alive and dead. That machines are so compelling and irresistible to somebody that wants to get a lot of things done is because it's essentially beyond time, right? That it just works 24/7, doesn't go to the bathroom or whatever. So I think you have to be careful when you say the technology is saving time, whose time?
I'd like to just bend this a little bit, and that is with the work we're doing with Microsoft. We're looking at a new stack that creates a new tool for humanity. And that new stack is the same stack that we have in every software program. That is, you've got a logic layer, you've got a data layer, and you've got an interface layer, right? So the logic now at the latest level is AI. So it's AI that over time rewrites itself. So it mimics biology in the sense that it's an evolving kind of technology. The technology isn't alive per se, but it evolves itself. The data layer, though, is very interesting. I developed early object-oriented and object-relational databases, so we've been doing a lot of work in database work. But the blockchain right now is our best defense against hacking. So the data layer now is moving.
So let's do a round on blockchain. Tell us what you think about
I want to
blockchain,
put the
and then we'll
context in about blockchain for a minute, because that's the key. Right now, if you interview people in blockchain, they don't know anything about virtual reality. You interview people in AI, they don't know much about blockchains. But actually, they're all just part of one stack. So the data layer would be, the latest data layer is the blockchain. The latest logic layer would be AI. The way you interface with that environment is through augmented and virtual reality. That's the way the human interfaces to the system. But then the AI then interfaces to the world and builds the world model through the IoT devices. So then you get these four separate realms, which are kind of distinct industries right now: blockchains, virtual reality, AI, IoT. They're actually all just part of one system, the way our body is kind of thing. And then the cryptocurrencies we're seeing are really just tokens. They can be used in the case of like NFTs and things like that to raise money, but they're also information to the AI. Where is the energy going in the system? So tokenization is ultimately still information. We can make it into a currency. We can do other kinds of things with it, but fundamentally it is a token or a piece of information on a blockchain, and therefore it's more secure than what we've got right now. As we know, there are no firewalls for our current relational databases. They're just vulnerable as hell.
Gurdeep, do you have a blockchain position or just AI?
I mean, other than the fact that I think, given the evolving architecture of the network, given the evolving architecture of the software layer, and AI, rightly put, programs are being replaced by models. I think that this is the best way to do security, and it's got the right kind of a distributed model, and I think there's a lot of the sovereignty aspect of it, which is very important. So I don't have anything more to say.
Okay, Bob, do you have a view on blockchain? I mean, obviously George is very excited about it. Yeah.
I know that everybody, all the professors and all the students at the University of Texas thinks blockchain is the next big thing.
Yeah.
That's all I know.
Okay. All right.
Let me give you one little practical story. So separate from our commercial company.
If you have questions, go ahead and line up for our panel. You can line up at the microphone.
I know. Separate from our commercial company, we have a nonprofit called the Open Earth Foundation, where we do a lot of nonprofit work around the climate and income inequality and other kinds of things with our technology. And so it's a nonprofit, and so we were looking at funding it. How are we going to fund it? How do we want to fund this project? We were just doing pro bono work through it, and then the NFTs came out, and suddenly an artist sold one piece of art for $70 million. Digital, his name was Beeple, that's his nickname, and the whole art world and everybody kind of woke up and went, what is this NFT thing? My God, $70 million for one painting, and so they got a little bit of pushback though, because hey, you're kind of messing up the environment because all of the mining that has to be done for the tokens and all that kind of thing. So we said, hey, look, we're doing a whole lot of work in climate accounting. Why don't we create a green NFT? So when you buy the piece of art, it already comes with the carbon offsets for the mining. Oh, cool. So we said, well, okay, we'll do that. So people said, hey, that's a great idea. That kind of takes the sting out of the NFT thing. I'll give you a piece of art, and a bunch of other artists gave a piece of art. We raised $6.6 million in 48 hours with NFTs for the nonprofit. So that's a practical application of blockchain.
Are you familiar with the scam where the painters sell their paintings to each other?
Yeah, I have. Yeah.
Oh, okay.
Go ahead, we have a question.
Hi. Hello. Thank you.
You can direct it to somebody specific or to the whole panel.
Jeff Gonison, Anchorage and Maui. That's a diverse. So my question's on security and the word blockchain up there. When you have your information in the cloud, it's actually on somebody's server in some warehouse somewhere. That warehouse goes down in an earthquake or blows up or something, it's gone. Or it can be hacked. But cannot you take data and spread it out like the blockchain spreads out its data so that it's not hackable? Your information is secure and you don't have to have all this security networking stuff under your belt.
So is that to somebody particular or
No, I did. Yeah,
just anybody wants to take
Yeah,
that?
obviously you need it all. Blockchains give you a certain level of security. If any chain doesn't reach consensus with all the other 1,000 or more copies of that data set, then they're taken offline immediately, of course. And then you still use all your other network security tools as well. I think Gurdeep said it really well. Security is going to be with us the whole way. I mean, it's just part of the deal, especially as more of our critical systems become automated. What Tesla's done is they said, look, it's all about autonomy. But there's 5 levels of autonomy. You don't just go no autonomy, full autonomy. You go through 5 levels of autonomy. And so we're creating an autonomous global economy and system, and we're probably at level 1 of it right now. Some things are automated, not very many, but probably by 2100 or 2070, we'll be a fully autonomous automated globe, and that handles climate, that handles robotic assembly lines. We're talking to one big company. They have 600 different suppliers for their clothing lines, and they want to move to robotic factories, because they can't control the quality in all 600 different suppliers. So you can kind of see where we're going with it all. We're going toward just like Tesla's doing for the individual car, we're going to do that now for the entire global economy.
Go ahead, couple more questions.
Yes, my name is Steve Trost. I have a question about the paradox between blockchain security and quantum computing. So the distributed nature of blockchain allows us to have our individual data distributed all over the world, but it's secured, it's encrypted by my own private keys. But since it's immutable, it's stored there forever, at some time in the future, there's the potential for quantum computing to break the cryptographic keys that I've stored all of my data on, and once it's out there, there's no way to erase it. So how do you solve that paradox?
Panel?
Hey, I'll take that. I think there are, there's a class of crypto algorithms called post-quantum cryptography, which actually relies on, basically, the big sort of underlying context here is that almost all crypto we know today is based on one observation that it is very hard to factor very, very large numbers. And that when quantum computing came along, there was something called the Shor's algorithm, which basically said that if you have 70 qubits, something order of that, you can actually crack a fairly large 2048-bit number. You can factor it in 100 seconds. And that basically blew up all notions of security that we knew. But since then, there have been tremendous amounts of work on post-quantum cryptography, which is not based on factoring numbers. So it's a totally different science and math, which so far quantum algorithms are not able to crack.
Dr. Love earlier today convinced me that quantum computing isn't going to happen for decades. Is that right?
Well, she should know. She's my peer who's focused on quantum computing. I will say that we are, again, incrementally making progress towards it. And there is one particular area which is not getting enough attention, which I love, and I think, Bob, you would love to, is quantum networking. So quantum networking is the idea that you can, using the optical channel, you can send an entangled particle. So you take two quantum particles which have the quantum mechanical property. You entangle them and you send one using optical as a photon to the other end. Once you have established that, you actually get like the only interceptable perfect security that we have never experienced. Even if you take a human being and said you physically carry a secret there, even that is vulnerable, except this one is not because it is based on physics. I think this is a good small step. I think it is even relevant for security on classical computing because it's not the key distribution model. It is actually you get your security out of the entanglement, out of the two particles, and you extract it from that and you use that for crypto. That is a good first step. I think single qubit operations, moving on to 4-qubit operations. I think this decade, what she's saying is, getting to a 70, 80, 90, 100 qubit stable system, I think will take 7 years, 8 years, 10 years.
So I'm going to allocate.
But
go
was
ahead,
the
Bob.
worry, was decrypting one of the apps in the zoo?
Yeah.
It was in the zoo, I didn't notice. You know the zoo that she put up of all,
I wasn't here for the presentation,
I'm
but
sorry.
yeah.
there were a bunch of apps that are going to be valuable early in the history of quantum computing.
Yeah.
But the question is decrypting one of the
Yes, it is.
apps
It is
in the
one of
zoo.
the most canonical examples. The Shor's algorithm is the canonical example for quantum computing. It is. But good news is that NSA and they've been working on post-quantum cryptography for 10 years. They've now ratified 3 standards. A lot of security stacks like Microsoft Stack, you can already get post-quantum cryptography.
Quantum proof.
Yeah, already built into the system, so you're future-proofed. Because otherwise somebody could capture the data, come back 10 years later and crack it. And NSA can't afford to have that.
So I'm going to do a 30-second wrap-up, and then we'll thank our panel. And this is an advertisement for our future panel. And that is the answer to your question, and the answer to security is this thing called disconnectivity, right? That you do not connect, that essentially as an end user, you control who it is that you connect to. That this notion that your box that Apple gave you and everybody that puts some software on it controls it is crazy. That really you need to control, and I think there was a hinted at one of the questions, you need to control, and everybody else asks your permission, not you asking somebody else permission to protect your privacy. We'll call that Disconnectivity Dimension chapter in COSM, and we'll get to that. But let's please thank our panel. And